All right, so if anyone's just joined us, we are just waiting until 5 past just to make sure that everyone who wants to join can join. But feel free to introduce yourself in the chat, and welcome to the event. So if you haven't been to one of these events before, you probably don't know me, so I'll just introduce myself quickly. I'm Lucy Gullen, but you might know me as Lucy Morgan, and I'm an AI and optimization research specialist at BT, but also a visiting researcher at Lancaster University, and I'm on the OR Society research panel and on the OR Society ECR committee. So yeah, and there's my details to get in touch if you do need to get in touch after the event at any point. So okay, I think I'm going to get going because I want to make sure we've got maximum time with the speakers. You don't want to hear from me any more than you need to today when we've got some really good talks to come up in the next couple of well, in the next hour. So coming up today, we've got talks from our 4 speakers who are coming to us from across either academia or industry. So each of our 4 speakers today have either gone from academia to industry or industry to academia, and they're just going to share their experience of their career path, and we're going to have some time to have Q&A with them as well. So really excited to hear from all 4 of our speakers who are really, you know, experienced operational researchers and or working in analytics. And then right at the end of the event, we're probably going to spend about 10 to 15 minutes, not too much time, because I know networking on Zoom doesn't work out so well all the time, but we'll have a little bit of time to do a bit of networking. We'll separate out into Zoom rooms that are just a bit smaller, so you can actually meet a few people in the ECR network and maybe make some more connections. Okay, so just a little bit of housekeeping. So if you can make sure that you're muted and you know, you put your camera on, put your camera off, whatever you want to do. We'll be using Zoom's chat feature for everything. So if you do have a question during the talks, please do put it in the Q&A, because we'll be reviewing the Q&A and Laura and Wendy will be asking questions at the end of the talks. Don't worry if we miss your question. We'll have a bit of an extended Q&A if we need to at the end of the talks to catch any that we miss. Do keep your questions about the talks. If you do have questions about the OR Society, you can ask them to us either at the end of the event, or you can put them in the LinkedIn group, which we'll put a link to the LinkedIn group now into the chat, or during the event into the chat, so that you can, if you haven't joined already, you can join our LinkedIn group, and that's kind of where we disseminate information about the Early Career Network. And yeah, do let us know if you've got a question for a specific speaker, because then we can make sure that we direct it at the right time. Any problems, just let Carol know. She'll be monitoring the chat as we go. And yeah, we'll be using the chat feature instead of raising your hands, but there will be more chance to actually chat to people at the end of the call. Okay, so that's the boring slide. Okay, so a lot of you will probably have been to Early Career Network events in the past, but if you haven't, then welcome. Basically, the aims of the network are for a bit of peer support and to try and send out information that might be ECR appropriate. So if you've got any questions or you know, you want to promote your work, or you want to celebrate an accomplishment that you've made, we hope that the LinkedIn group is somewhere that you can share that with your peers. And we're actually also sharing information in there on different opportunities, training events, workshops, etc., that come up that we think might be good opportunities for ECR to join. For example, I can't remember the name of it now, so well, any opportunities that come up we will share in there. So do join us on LinkedIn, and we'll share you the link as we go, so you can learn about our next events. So the plan for the next event is to have it actually in person at OR 64, which we hope a lot of you can join us for, and that means we can do a bit more natural networking. Okay, If you're interested in getting involved, we're going to start to cycle our positions each year. So the ECR committee actually, or the ECR network only started in a couple of years ago. And since then, Wendy and Laura have recently joined the committee, and I will be cycling off the committee at some point in the next few months. So we'll be looking for a new future chair to come into the committee, give us some new ideas, and so we can keep cycling through these positions. So if you're interested in getting involved with us, it's really fun and it's not that much time commitment, and you get to come to these great events and actually talk to some really interesting speakers. I can't say I've found any fault with it. So if you are interested, let Carol know, or do get in touch with one of us. You can find us on LinkedIn or you can email. Okay, oh, that's the end slide. So what I'm going to do now is we'll go to our first speaker. So our first speaker for today is Peter Frazier from Cornell University. Have you got some slides you'd like to share, Peter?
I do, yes.
Perfect. So I'll stop sharing and I'll let you set up.
Wonderful. Okay, let me go ahead and share screen here.
That's perfect. You can see those. And yeah, whenever you're ready.
Okay, great. Yeah, so thank you, Lucy. It's wonderful to be here. I really like these kinds of events because the decision about whether to go into industry or go into academia is a really important one. And they both have great things to recommend them. And the right choice for you, I think, depends on what you like. And it's, so it's great to be able to maybe help a little bit to people to make that decision. So I work both in academia and in industry. I'm a faculty member at Cornell in the operations research department there. And I'm also a senior staff scientist at Uber. And I have a half-time leave from Cornell in order to be able to do that. So let me just tell you a little bit about the work that I do for both Cornell, in academia, and then in industry for Uber. So at Cornell, I work at the intersection of operations research and machine learning. One of the areas that I've worked the most in is something that's called Bayesian optimization. So in Bayesian optimization, we have an optimization problem, and evaluating the objective function and any constraints may be really time consuming or maybe really expensive. For a big kind of important example that's had a lot of impact is designing and designing deep neural networks. So that's a situation where you'd like to find the architecture for this machine learning algorithm that's going to provide the best predictions. In order to evaluate a particular architecture for a deep neural network, you need to train it and then test it. And that might take, many hours on a very large computer. So Bayesian optimization, the idea is that we're going to use machine learning in order to model the objective function, to model the constraints, and then use essentially reinforcement learning in order to decide, or stochastic dynamic programming in order to decide at which points in the input domain we should evaluate the objective and constraints. And so we've done lots of methodological and theoretical work, designing algorithms and analyzing algorithms in this area. And then we've also done a lot of applied work, for example, deploying these Bayesian optimization algorithms with partners at companies. We've done a lot of work with Yelp, a company based in San Francisco that provides mostly restaurant reviews, but also other kinds of business reviews. I had a former student who started a startup company called SIGOPT, and they were recently acquired by Intel. And then we have a longstanding partnership with folks at Facebook, and they make an open source code for doing Bayesian optimization that we've been lucky enough to have them implement a number of our algorithms. Yeah, and then we also think about applications in the design of engineering systems, and then more and more applications in the design of new materials and the design of drugs. And if you're interested, there's a tutorial on the archive where you can read more about this area. So that's one thing I do. Another kind of closely related thing that I work on is multi-arm bandits and online learning. This tends to be more theoretical. I'll just mention a couple of keywords if you happen to work in this area. If you don't know these keywords, that's totally fine. Yeah, so we're interested in Bayesian bandits and dueling bandits, so in a bandit problem, one faces a collection of options and one needs to allocate effort across these options in order to maximize some total reward. And we have uncertainty about the value of each of these options, and the difficulty is in understanding how to balance trying something that we know is going to work reasonably well, versus trying something new that might work badly but might work great, and then we can exploit that information in the future. So it's all about kind of managing the collection of information. And then at Uber, so what happened was, one of the great things about being in academia is that you can go on sabbatical and you can do essentially whatever you want for half a year or for a year. So I thought it would be interesting in 2015 to go and work at a company in the tech sector. And Uber is essentially, it's an operations research company, because they do transportation. And I thought that what they were doing is really interesting. So I joined as essentially not quite a full-time employee, but almost a full-time employee for a year, then was able to extend that to a second year. And then I came back to academia half-time, and now I balance my effort. So what I currently do for Uber is I work on driver-side pricing. One of the things that you want to achieve when you operate a ride-sharing market is to set prices so that on the one hand, drivers are happy to accept a rider's dispatch, but on the other hand, riders aren't paying too much money. And that's difficult because riders are always comparing what they can get by accepting a dispatch versus rejecting one. And so if you make different dispatches, different trips, such that kind of the net utility a driver can get out of them is dramatically different, then what's going to happen is that drivers are going to reject the one that has low utility and in favor of accepting the one with high utility. So you want to, in kind of game theory jargon, you'd like to make accepting all dispatches incentive compatible. So that's what I work on now, with the goal of improving the efficiency of ride-sharing markets, helping drivers earn more money more quickly, help riders get where they're going at a price that they're happy to pay. Previously, when I was a full-time employee, almost full-time employee at Uber, I managed the data science team for Uber Pool, the ride-sharing product, which was put on hold during the pandemic, but is a way for a ride-sharing system to be able to, get more efficiency, both from an environmental perspective and from allow us to pay drivers more for a given amount of effort by having riders share a vehicle going in their direction. And then more recently, since the start of the pandemic, I've been leading what we call the Cornell COVID-19 mathematical modeling team. So this started at, kind of spring 2020, near the start of the pandemic, where I and some of my colleagues and two of my PhD students were interested in the use of regular testing of people without symptoms for COVID as a way to control the spread of the virus. And then we linked up with some like-minded people who are in Cornell's College of Veterinary Medicine, who happen to have access to the ability to run a large number of PCR tests. That capability was built in order to support actually dairy herds and other, sort of animal herds used to make food in the area. And so we repurposed that to test people for SARS-CoV-2, and we're able to use that in order to reopen safely in the fall of 2020, where we instituted a program where students were tested at least once a week, and that was able to support a safe reopening. We've continued to support the university with mathematical modeling and data science through the pandemic. Yeah, so that's kind of where I come from. Now, I'll offer a couple thoughts, and then I'm interested to hear questions. So academia and industry are very different. They're both great. So in academia, the focus is on understanding the world, on building an understanding that will last, essentially forever. Sometimes that takes the form of, working on applied problems. Sometimes it takes the form of working on theoretical problems. But the focus is on, solving a problem completely, documenting it for humanity, and that's great. In industry, the focus is on helping your specific company have a better business, essentially to, if you're working for a private sector company, to improve that company's profits. And that, that aligns somewhat with understanding the world, because, if you really want to do a good job in improving profitability, it helps if you, kind of understand the business and you understand the mathematics of the problem that you're studying. But, as soon as those two things depart, understanding the world and having business impact, if you're working in industry, you need to focus on having business impact. One of the consequences of that is that in academia, you're typically given the time, or you take the time, to be able to solve problems completely. In industry, that doesn't typically happen. Instead, you start with a problem, you make a couple of improvements to the business, then you ask, hey, if we continue to work on this, how much better is our solution going to be? And at some point, the improvement that you're going to get by continuing to work on it is smaller than the improvement that you could get by working on some other problem. So you stop working on that problem and you pivot and work on something else. So the projects are much shorter in industry compared with academia. In industry, it'd be really weird for you to work on a problem for a year or 2 years. At least at Uber, that would be unusual. Whereas in academia, that definitely I'll work on papers for 2 years. In industry, there's more support around having impact, especially short-term impact. In academia, you can have impact, but you need to go after that a little bit more, and be a little bit more self-directed than you would be in industry. In academia, you have a lot more freedom. You can work essentially on whatever you want to work on. And that's really, I think, a wonderful thing. I started working on material science and drug discovery. And, I'm an OR person. So, and nobody told me I couldn't do that. And it's great. Whereas in industry, you can only really work on what's going to help the business make money. I think that in industry, by and large, it'll depend on your specific situation, but the pay tends to be better. In academia, again, it depends on your situation, but if you're a tenured faculty member, you're going to have better job security. I've been laid off. I worked in industry before, also getting my PhD. I've been laid off several times. If you work in industry, at some point you will be laid off. But if, probably my tenured position at Cornell will last until I decide to retire. So, very different situations, but both have great things to recommend them. Maybe I'll just offer a couple thoughts on if you're in academia and you want to make a jump into industry, just some things to think about that might help you. So one is that I find that when we interview people from academia for positions at Uber, especially if they're, they want to come in and spend a year and they're a faculty member, or they're a new PhD, a freshly graduated PhD student who wants to work in industry. It really helps to focus on communicating with people from other backgrounds, especially non-technical backgrounds. Think about, what are they taking away from this conversation, and how can I change what I'm saying so that it's really going to resonate with them? Simple thing is, when I first started at Uber, I would explain ideas on the whiteboard with notation involving Greek letters. I realized that if I dropped the Greek letters and instead put in numbers that were the actual numbers that were kind of typical for the business, it was much easier for people to understand. Just one example. Understand the business. Let's see, I think I'm running out of time. Is that right, Lucy? How am I doing? Doing okay?
A couple minutes.
Okay, but I want to say again.
You've got a couple minutes. That's fine.
Couple minutes. Okay. But I want to take some questions. So another thing is to understand the business end to end. In kind of academics, they tend to abstract things, and abstraction's wonderful, but don't let the ability to abstract obscure the kind of the gory details of the business. What matters, what doesn't matter, what's first order, what's a rounding error in terms of the bottom line. Instead of optimal, people don't care about optimal. Instead, care about improvement over the status quo. Another mistake that I see academics make when they come and work with me in industry is they want to build a full, complicated, perfect solution, and they want to spend 6 months doing that. Instead, think about, what is the minimum thing? What is the big thing that's currently broken that we're going to fix? And then build a really simple to deploy strategy that addresses that. Let's deploy it and address it and see if it works. And that way, if our whole kind of thinking about the problem is wrong, we're going to find out in a month rather than in 6 months. And then that 5 months that we save, we can spend on something else. Think about, what is the first order thing in the business that you're going to fix, and make sure that your solution does that right. All the second order things you can get wrong, but you have to do the first order thing right. Also, there should be a simple reason why your solution is going to work better than the status quo. It can't just be that we wrote down a mathematical model and we optimized the mathematical model. There's something intuitive in the business that you're fixing, and if you can explain that, that's going to make it more likely that your solution is actually going to succeed, and it's going to allow you to communicate with stakeholders, non-technical stakeholders, about getting your idea launched. And then also think about all of the engineering constraints and the political constraints that are operating, whether you realize it or not, and design your solution so that it's gonna fit with those things. So let me stop there and see if I can answer any questions.
Thank you so much, Peter. That was great. I mean, actually, before I'd heard you speak a couple of years ago, I had never even thought about doing a sabbatical that was with industry instead of a sabbatical that was with, I don't know, a university somewhere else. And I think more people should be thinking about doing that, because look how rewarding it's been. So I'll just ask a quick question, and then I can see that some questions are coming up in the chat. So everyone can use this time to write in questions they want to. And thank you to everyone that sent in questions previously. So for you, Peter, it's quite obvious that your academic career benefited you when you were going into the industry because you had so much to give. But have you found that work that you've done in industry has inspired new research for you?
Oh, definitely. Yeah. For example, right now I'm working on a project which came to, it's a theoretical project about often what we do is in in industry and in academia is we estimate some statistical parameters, and then we plug those parameters into some structural model for the world, and then we optimize the model, assuming that the parameters are accurate. And what I've found in industry is like sometimes that works great, and other times that works terribly. And there's a bunch of like kind of intuitive rules that we use in order to understand whether something's going to work or not. And so I'm writing a theoretical paper that's about kind of codifying that from a kind of mathematical statistics perspective. Yeah, so like that's one example. Yeah, lots of the time I'll come into a problem that is a practical business problem. We'll solve it from a business perspective, good enough, and then I'll come over and I'll study it in a deeper way in an academic setting, and it's been very rewarding.
Sounds great. Wendy, is there a question in the chat, Peter?
Yes. There are two questions. First is like university emphasize more on the impact of research and ask for more paper output. So does this impact the ability to understand the world and to push more towards focus on the business impact?
Okay. Right. So I guess, yeah, so different universities are maybe a little bit different. So in terms of what they're looking, different departments are different in terms of exactly what they're looking for. Some they're looking for kind of real world impact, like did someone adopt the algorithm that you proposed and then use it to save $1 million? And then other people would like to see you publish in top journals. And I think that the universities that kind of put a focus on one or the other, I do think that they incentivize the researchers that work at those universities to kind of aim at accomplishing those goals. Yeah, and I think overall that's probably a good thing. Maybe we can do a little bit better in academia in terms of thinking about how to incentivize work so that it's kind of most beneficial to society in the long run. I don't know. I hope that helps.
I think that's a really good point.
Follow up and clarify the question.
I think we've got to, we're going to move on to the next speaker now, but I've just seen there's a great question from Florian in the chat. So if you want to answer that now in the chat, Pete, you can, or we can come back to it at the end, depending on whether you can stay around or not. So great. So I just want to thank you again for your speech. And Jeremy, have you got some slides you want to share with us?
Sure, I'll just share them now.
Thank you. So yeah, our next speaker is Jeremy Bradley from Datasparq. I can see those as well, so that looks great. Thanks, Jeremy.
No worries, thank you, Lucy. Very kind, very nice of you to invite me, and really enjoyed listening to Peter there about his experiences. A lot of that chimed with me, certainly. Anyway, yeah, hi, I'm Jeremy Bradley. I'm from a company you probably haven't heard of called Datasparq. And the reason you haven't heard of them is that they are, if not a startup now, but they were when I joined them. I think I was employee number 5 or something back in 2020. And yeah, it was an interesting time to be joining a company and starting a new role with a startup. But yeah, I'll come to that anyway shortly. In terms of my background, I haven't actually got slides on this, but I'll just tell you anyway very quickly. But I don't really think I'm the person of interest here. But anyway, so I was an academic at Imperial College for 14 years, and working in OR, sort of queuing theory, probabilistic modelling, stochastic modelling, communicating agents, anything in that sort of sphere, which is quite large, but also quite a broad area, and quite it created interesting issues in that it was quite difficult to focus on particular application areas. You had to have those collaborations and sort of use cases, if you like, to narrow it. But yeah, it was a broad research area. Learned loads, worked with some terrific people, had some great PhD students and postdocs, and yeah, had a really nice time doing that. And I enjoyed the teaching, I enjoyed the research, I enjoyed some of the admin, should we say, but mainly the teaching and the research, if I'm honest. We'll talk about that later, maybe. So yes, and then after about 2015, I decided that I was really keen to see some impact from what I was doing. As I said, I was sort of possibly struggling to find areas where I could really focus my efforts and contributions on a particular problem, a particular industrial case study. So I helped to set up the data science team at Tesco, and so I came in an early stage there. Tesco, for people who are not in the UK, is a large supermarket in the UK, and we worked on some terrific problems in optimization, vehicle routing, forecasting, standards of machine learning around sort of store product makeup and what goes into stores and how they should be laid out and that kind of thing. So very exciting, and then really started to see some interesting impacts from that, which was quite, when you start to get that, it's quite addictive. It's quite nice to see a project you've worked on, sometimes it doesn't sometimes for quite a while, actually bear fruit, start to, yes, there's a financial win, there's a financial focus that Peter talked about, but actually there are other maybe less tangibles. There's the fact that the project that worked on with grocery home delivery vehicles coming out of Tesco, continues to save 20 to 30,000 tons of CO2 a year from going in the environment, which is more than I'm ever personally going to save by doing anything individually, but definitely a really nice outcome from a project. So that's lots of fun. And then so there's some nice things that you can take from that kind of project, which are aligned with the business, but also sort of extra, not necessarily bottom line focused. And then moved to the Royal Mail and helped to grow the team there. We had a terrific team, 25 data scientists working across a lot of optimizations, you might imagine, because they're predominantly a logistics company, and also sort of sickness prediction and revenue protection. The nice thing about working in data science teams is very much that they are so broad in their applicability of what they do, and so there really is. If data exists in a particular area, it doesn't always, then you have the opportunity to have an explore, see whether there's a project which is worth going for, see what the value is, and execute a good project potentially. One of the nice projects I worked on there was looking at diversions of heavy fleet and how we could make heavy fleet movements across the UK much more efficient to avoid motorway closures overnight. And because the Royal Mail obviously has a massive fleet, largest fleet in Europe, they were sampling the motorway network every night, almost without fail. And so they had a really rich data set on what the travel times between two locations on that motorway network looked like. And we were able to come up with a model which allowed them to recommend better diversionary routes when motorways are closed, which was a really lovely project, still used today. Again, saving a lot of wasted journeys, a lot of wasted hours, a lot of improving the quality of delivery of the post, which was actually quite timely when it came to lockdown, and people were much more intent on, much more relying on postal delivery, mail delivery, parcel delivery. Of course, was all impacted by that kind of ability. So yeah, that was a nice project. And then subsequently, as I say, moved to a small company called Datasparq, which is a professional services company, a consultancy, where we basically get to set the weather. We get to sort of choose projects where we think that looks exciting. That matches our skill set. That matches something we really want to get into, and we get to define our own sort of mode of transport, as it were. So yeah, that's been lots of fun. I'll talk a little bit more about that. So anyway, the question was, what you need to know moving from academia to industry. So I just wrote down a few things. I thought I'd just run through them really, and then maybe answer some questions at the end, and I can talk about other things I do if you like. The problems tend to be more specific. I think Peter sort of alluded to this. They tend to be, in academia, you tend to have quite broad problems, quite general problems. You're looking for the best solution, the optimal solution. In industry, you tend to be looking for, certainly in the data science teams I've helped run, I say, look, we're interested in better. We're not, if best is great, but we're interested in better. And often if the better is sufficiently better, then it can be super valuable. And typically it can be a lot easier to get a slightly better solution. It can be to get a best solution, if you like, a global optimum. So really, you know, having that sort of mentality, it drives some of the approaches that you go to. It drives the whole style of problem execution. And as I say, yes, they tend to be more specific, they tend to be more focused, they tend to have a lot of detail and constraints, especially if you happen to be working in an optimization problem. One of the problems we're working at the moment is on international logistics company, and they have a lot of detail around driver operating procedures, break times, meal times, maximum duty length, minimum duty length actually, and you know, which lorries they can get into to go to a particular location, because there are very, very specific constraints at particular locations in the network and so on. So you get this, you really do, the difference between working in an environment where you don't have, it's pretty unconstrained, and one where you work in an environment where you have a lot of constraints, which actually leads me to my second point, which is that actually, as you know, if you work in optimization specifically, but there are lots of other areas that I haven't touched, there is significant technical challenge in adding highly complicated constraints, and also ones which are, yeah, I mean, detailed in the individuality, but also there's just a lot of them, and that can cause a very quickly we move out of sort of complex optimization spaces and move into sort of heuristic, meta-heuristic style optimization approaches to be able to just make any progress at all in terms of that kind of problem. So yes, but I find personally, and I think it very much depends on the individual, I find the minutiae, the detail around these industrial problems to be really quite fascinating. And often there's a nice story behind why there is a particular configuration of a problem, or a particular constraint, or a particular way of working. So, and that is interesting to hear, interesting to learn about, and sometimes interesting to guide. You can say, well, if it needed, I can see why you had that once, that reason why you stop at those particular locations, but actually there's an efficient solution which means you don't have to anymore, and it would drive a slightly, you know, an improved solution for you, and it would save you a certain amount of money. Maybe you could think about changing your way of working to accommodate that. Maybe it would be worth doing that. And so you find there's a lot of reasons for a lot of ways of working in industry tend to be historical and tend to be driven from, well, that's what we have done, and when data is available to actually prove that that something could be done slightly differently, then it becomes more of an interesting discussion about culture and change and all of those kinds of things. A few other things I really learned. The team really matters. This is a few months ago. The team I happen to be in, we're already 20 strong. We're probably 50 strong by this time next year. So it grows fast. It changes quickly. You've got to really focus on both developing the team, growing the team, keeping the team up to speed and sufficiently upskilled. But the execution as a team is hugely challenging. And it's not that there aren't teams in academia. There absolutely are. I had 2 or 3 PhD students and a couple of postdocs, you know, running simultaneously. But even then, that was quite a tight knit group. In a research group, and you know, now I'm, you know, in charge of sort of 4 concurrent, 5 concurrent, 6 concurrent project teams running on very different and diverse projects. So I have to, you know, I have to choose which ones I'm going to be in touch with. I have to sort of define, you know, high quality ways of working so that they are essentially able to look after the minutiae, the problem solving process, and get to a good place with that, but still drive some good effect and good results for the company. Yeah. So what else? The time frames, I think Peter alludes to this, a lot shorter. So typically, you know, in an academics issue, and this is a strength actually. This is both a strength of academia and a strength of industry. I knew this when I moved to academia, to industry, and it typically, the projects we execute are 1, 2, 3 months maximum in length, whereas obviously in an academic setting you have a research project which maybe lasts 3, 4, 5 years, and a PhD student who's working on something for 3 years and a postdoc for 2 years or something like that. So you just have that breadth of time to really go, oh, we can really take a much longer perspective on this problem. And I think this, for me, is where the two worlds are really complementary. And of all the companies I've been at, I've made a real effort to set up this sort of academic liaison activity and talk to really great academics who are working in key areas like sort of reinforcement learning and Bayesian optimization and NLP and meta-heuristics and what have you, because I know that they're taking this longer perspective, that they have a view of the latest and greatest approaches, which we wouldn't have time to develop, but we certainly have time to find out about, and we certainly have time to educate ourselves about and then use. And then they in turn are really excited by the fact that hopefully we're taking some of their techniques or some of the techniques from their area and being able to deploy them, get impact, and then, you know, help with research case studies and research impact and that kind of thing. So yes, time frames are shorter. I think inevitably you have to be able to show that you can deliver some value in a particular time, and that people tend to not have quite as much patience as, say, EPSRC expect. Okay, but at the end of that, you have some great stories. You know, stories like, you know, grocery delivery to 98% of the UK, or you know, parcel delivery up along with the UK's motorway network, or yeah. So I mean, we're also, as it happens, working with a ride-hailing company at the moment, not Uber, but we're deploying some really nice technology with them, and I think it will be a really nice case study that we can refer back to once it's in place, and you know, it'll be a great use of optimization and, you know, machine learning to demonstrate how you can dynamically morph the supply and demand in particular areas to generate an effective and efficient marketplace, essentially. And yes, I mean, there's some lovely stories that we can work with, and that's definitely a plus when you're working with in an industrial setting. Yeah, so I think I'm going to stop there. I think that was my presentation. I very kindly, somebody asked me a question before I came in. I didn't realise when I looked at the document. He said, "What have you gained and what have you lost when moving from academia to industry?" So I think one of the things I gained was, there's two things. One was more personal, and I suppose they're both personal. But yeah, so one was I gained more family time. I'd started a family myself, and my partner started a family, and I found it very difficult to juggle academic sort of life, which seemed to just eat up every second of the day, with having a family. Whereas in an industrial setting, I found it much more manageable. I found it I can define the boundaries of my work, and I very much, as I run teams now, I very much encourage them to define their boundaries. And, you know, I'm not saying that I never work late. It does happen, of course it does, but I don't find it completely dominating my every waking hour. I can turn off, I can put things to one side, I can have time with my family, and I think that's really important, personally speaking. And I think another thing that's important to speak about is that when I left academia, I was suffering from mental health wise, and I wasn't enjoying that process, that experience at the time. And I found it, just the total reset and change I got from moving into industry enabled me to recover my mental health, enabled me to reset my priorities and reset what I wanted to do with my life, and that was extremely healthy. But I did find it quite challenging before in academia. I had been there for quite a long time, yeah, there were definite challenges to be got over. So there are some things that definitely have got better as a result. I do miss some of the aspects of academia. I miss the teaching. I love teaching. I still do some teaching. I still do give guest lectures and what have you, and I enjoy that enormously. Yeah, there's some things I don't miss so much. Okay, I'll stop there, and I hope I haven't gone massively over.
No, that's great. Thank you, Jeremy. Thank you for your presentation and your advice, and for being so honest there. Actually, it was refreshing. So if you've got any questions for Jeremy, do write them in the chat. I mean, we've got a minute for maybe a couple more questions, but one of the questions that came in before the session I wanted to put to you was that, so there's a lot of us here coming out of PhD or just a couple of years into academia, and how would you say, if there was somebody out there thinking about going into an industrial role or trying that track, how could they prepare themselves or mitigate the challenges of that in your eyes?
Yeah, it's a great question. So, I mean, I can tell you, it's not quite answering what you were asking, but it definitely it's definitely a start. The things I look for in a really good data scientist, so someone who's coming in from, and bear in mind, I don't think of data science as being a specific field. I see it as being a confluence of many different areas of academic research and achievement. So, computer science, statistics, mathematics, yes, machine learning, of course, but importantly, or massively importantly, optimization and OR. So I think some of them I've alluded to. I think the ability to work in a team, the ability to be able to problem solve in a team and not by yourself. I mean, I'm not saying you shouldn't be able to problem solve by yourself, you absolutely have to, but the ability to be able to share a problem, bounce ideas off somebody else, then flourish together with those ideas and move forward with a better quality approach or a better quality solution is super important. Being terrifically, a lot of academics have this, but maybe and certainly when I was a PhD student, this wasn't the focus, but I think much more is now. The ability to be able to communicate and have fantastic communication skills, telling a narrative, telling a story, understanding the significance of what you're doing, what the problem is, pushing forward through a solution and getting to a new place where you have something to say, and why, and being able to explain why it's an improvement, why it's of value, is hugely important. Just getting stuff done, being able to, in the particular area I am, that can just be being able to code and being able to get stuff sort of translated from ideas and algorithms into some particular execution environment is very important. But the other two things I'm really keen on are empathy, which is not really something I can test for, to be fair, but just an ability to empathize and sort of look at somebody else who, because bear in mind, when you're an industrial scientist of any type, you tend to be pushing yourself into a field where you're not the expert, you're not somebody who has worked in logistics or van driving or shop stacking or whatever, diversion planning. There are people who are working that and they've been doing it for 15-20 years. You have to be able to understand what they do, empathize with that, pull it apart to some extent, but also know how to use the expertise which they have developed over that time, so that you can both construct something which is going to be valuable and effective, but also something which is not going to massively challenge them if they take it on as a new tool. You need to be thinking, how is this going to land? How is this going to change potentially their working life, but also how is it going to be compatible with their working life as well? And there's lots of good instances where fantastic science has gone to die just because it wasn't really landed in a particularly clever way or a particularly empathetic way in the team that it was being delivered to. Yeah, and other than that, yes, diverse problem-solving abilities I sort of alluded to earlier, you know, so the ability to solve in a team, but also to solve in ways which other people aren't solving in, which again is quite challenging because you're sort of looking for not necessarily successful problem solving, just different ways of thinking.
Thank you. I think that was really valuable, actually, and a really good response to that question. So thank you to whoever sent that one in. Okay, so I think there was another question for Jeremy in the chat. Maybe we can come back to that at the end of all the talks. But for now, I'm going to move on to our third speaker, which is Justin Tumlinson from Exeter. Justin, have you got your slides ready to share?
I do. I just have to find the right screen.
Perfect.
Okay.
Okay, perfect. You can see those, Justin. Thanks very much.
Okay, great. So it is a real privilege to be here. For one reason, I actually get considered as an early career researcher most of the time, and you will find out why in just a moment, because unlike the previous speakers, I'm going to talk a little bit about my career, not the details of what I do on a day-to-day basis, but the path I've taken, because it's probably why I'm here. It's a little bit unusual. And I suspect for many people who are actually early in their first careers, they imagine that the decision that they will take is a direction they will point in now, and there will be a monotonic progression in their career. And I want to tell my story because it's just not the case. That's not the way my story turned out. I turned out I was raised by missionaries in a remote American Indian reservation. And why do I tell you that? So my brother and I were the only white kids in school for 200 miles around. And this gave me this really peculiar take on race, ethnicity, culture that really deeply influences my research today. But what's important in this story is that my experiences from the beginning form this very unique kind of adaptability, flexibility to thrive in sort of interdisciplinary environments. I went to the nearest town 2 hours away and studied computer science. My interdisciplinary knack kind of published off really fast. I published 2 peer-reviewed papers as an undergraduate in psychology on how computers can be used to facilitate our understanding of the field. And in 1997, when I graduated, it was an incredibly fortuitous moment in history to have a computer science degree. Even from a place like Northern Arizona, you could get an amazingly high-paying job at a very prestigious company. I joined Intel actually as a hardware designer. But very quickly, I sort of got pegged as this general purpose analyst to support the decision-making of the executive staff. And after saving the company a few $100 million, I started to be groomed for a technical executive position. But they decided that my educational pedigree was going to embarrass the company on the annual report. So they sent me back to get a PhD in operations research at Berkeley. At this very same moment, I switched to Intel's advanced networking lab and Intel Capital, where I worked on things as varied as interplanetary internet in cooperation with NASA, and in developing Intel's corporate investment strategy in ultra-wideband and MEMS technologies at the time. And then after I finished the coursework in my OR PhD, but before I got serious about research, the dot-com bubble burst. My timing had gone from very good to very bad. I lost an incredible amount of money, Intel became a miserable place to work, and my actual odds of making the C-suite got pretty bad. So I quit Intel, took a leave of absence from Berkeley, and I leveraged that experience working at Intel Labs and Intel Capital and became a junior level associate at a VC firm in Munich. VC Venture Capital, for those that don't know the acronym. Eventually, I formed my own firm with several partners that started to manage assets and advised rich entrepreneurs who had turned into angels, ways that they wanted to invest their money in different ways. But I decided I'd started this pedigree hunt. I better go back and finish it just for the credentials. And then, just as one would expect of true love, research blindsided me. I absolutely fell in love with it. But once again, when I graduated, I got hit by bad timing. I graduated in 2011. The Great Recession had created the worst academic job market in 40 years. So I took a job at the IFO Institute in my old stomping ground in Munich, where the guy who recruited me said, look, all you have to do is researcher. There's no prestige, no particular money. That wasn't so important. But right after I arrived, my department's mission changed to policy analysis. My boss left, and I wrote policy briefs for the European Commission, translated the boss's books from German into English. There was a little bit of time for some research, though, which turned out to be fortuitous. But I recognized that this was not really the job that I had signed up for. So I added some teaching. I became a visiting professor at EM in France, taught a couple weeks a year so that I could prepare for a traditional academic job. And then actually, with a little teaching under my belt, I was lucky enough that my first paper appeared in management science, and I was able to land a research job at Loughborough University in just 2017. So that's why I'm an early career researcher. That's actually when I became an academic. And at the Institute for Innovation and Entrepreneurship, which is a field in which I had considerable private sector experience, which helped a lot, being able to tell the stories. I continue to find passion in my research, and occasionally a decent publication comes out. I was able to leverage that into my current position as an associate professor, or if you're in the UK, you recognize that as a reader in business analytics at the University of Exeter, which is of course a discipline that reaches way back, even though my PhD is technically in economics, way back to the days in which I was actually at Intel. So I still remain open to the reality and the opportunity that academia may not be my final occupation. We will see what new doors open, which ones close in front of me. What can you take away as an early career researcher from all of this? I think it's important to have goals. You need to move forward with them all the time, but you do not need to reach them. As you're moving ahead, it's like you're climbing some kind of mountain and you get a better view of the landscape. Your perspective becomes broader. You see opportunities you never saw before. I think it's totally okay to go after them, and instead of keep going and persisting in the direction you are heading. The second thing is life just happens when it happens. Sometimes that timing is great, sometimes it is not. And there's huge amounts of it that you cannot control. And I have been both the beneficiary and the victim of market fluctuations a tremendous amount in my career. That said, I think it is possible to prepare for the future. So my timing in venture capital, right, you can think about it, I actually entered right after the dot-com bubble burst, was terrible from the perspective as a moment to get rich. But it paved the way for me to start my own firm, and was really the inspiration behind the very first management science piece that I wrote, which would ultimately be the key to me landing my first academic job years later. The other half of the key that I knew I needed in order to land that job was to go out and get some teaching experience. So on the side, I took up a visiting professorship in France for a few weeks a year. The other thing that I think you were often told as an early career researcher, you just get your PhD, is that academia is a one-way street. Once you leave, there is no coming back. Now, obviously, my story is something of a counterexample. That said, it's hard, and I paid a price for that career path. One should not say that it comes for free. My classmates are all tenured at Harvard, Columbia, NYU, Duke, UCLA, and so on. And Exeter is a great university, but it's obviously not in the same league as my peers. So let me take another couple minutes and answer the questions that we received in advance, the ones that I think are particularly relevant to me. First of all, what helped my decision-making? I can tell you, I don't know if it helped, but certainly what I was thinking at the time. I was getting married right after my undergraduate degree, and I chose industry for the money. I made obscene money, but it didn't make me very happy. I think part of it was why it didn't seem like much is that my peers right next to me also made so much money. They had planes. One of my colleagues had a jet. They all drove Porsches, Lamborghinis. Money wasn't special. I don't miss it, the money. I gave up a lot. But I do miss, and I think you've heard this a few times from the other speakers, I miss the thrill of the hunt, if you will, making decisions that were worth $100 million in real time. I also sort of miss knowing exactly what the objective was all of the time in industry. In academia, there's a tremendous amount of ambiguity. which can sometimes cause you to fall into a little bit of a lull where you're searching around. Now, why did I choose academia? Really was for the intellectual freedom. I had this huge chance to spend a massive chunk of my life trying to understand what mattered to me about the world. The other thing I think that I realized in my particular case, and I don't think this represents the case for any of the other speakers that we've heard, is that industry and entrepreneurship was brutal for me at times. There were often situations in which you had to make absolutely ruthless decisions. And at the executive level, you were sort of surrounded by folks who had to make or did make ruthless decisions as well. And I did not love my personality in those moments. I did not also like the sort of outrageous displays of consumption that I was always confronted with. And to be fair, the folks I hung out with at the upper levels of Intel and in venture capital were brilliant folks, definitely smart enough to be really successful academics. But they were just not noble-minded in the way that I define it personally. And so academia is full of really bright people that you get to spend a lot of time with. They may or may not be effective, but they really want to improve the world that they live in. And so for me, that was a big difference in who I got to hang out with. Next question was, how does work-life balance compare in academia? I think that this is a really difficult question to answer, because I will say that I think that the minimum demands of a tenure track job at a research university are higher than the minimum demands at typical industry employers. But both at industry and in academia, there is a level of competition in both that is more than you can possibly handle. You just have to pick what life it is that you want. I have managed through this career to be happily married for 25 years, raised 2 sons. The oldest is in med school now. The youngest wants to follow in his steps. I live in Munich. I commute to Exeter in England. As it turns out, I take the time to cycle 100 miles a week in the backcountry. I go to the gym. We entertain a lot in the house. House is full of art, music. I feel balanced, but very tired, and I wouldn't have it any other way. Oh, and then there's this question, I'm sure this one is for me. What are the challenges in moving from industry to academia? Because I think this is sort of my story. The 2 main things, I think you've heard this, but it's actually really hard to tighten your belt in terms of the drop in salary. If you have grown accustomed to industry money and then you move to academia, the cut in pay is really, really significant. I'm very fortunate that, I sort of have a long career before, and so I can sort of supplement my income from other things I do in about the same measure as my academic salary, but it's still a huge drop, to be frank. And it's not so much about you, but it's about your family and things that you have acquired. I have a very special wife who really doesn't care about money, but that may not always be the case, and making that adjustment could be very, very difficult. Second thing I think that's really difficult about this switch is your rank in academia is determined by the number of papers you publish and the rank in which those papers are that you have published since your PhD. Nobody really cares what else you have done. So I was very lucky that my single first paper when I moved into academia was in management science. Had I gotten a little less lucky and it had gone somewhere else, I probably would have had a very difficult time. But, I still had to start, because of that long detour in life, sort of below my ability, and I'm still sort of crawling my way up. What can I say about the industry view of academia? I think they're impressed, right, by academic credentials. The problem is that they don't necessarily have the same sense of academic quality that we do. When I worked in industry, people were publishing papers, but they were nowhere near the same kind of level of intellectual rigor that you would think that we have to publish in top journals as academics. It's just a different measuring bar. I think the last question is, would I consider another career move? For sure. I am pretty realistic about the fact that my days proving theorems are probably fairly limited. I could go back to venture capital again. I really enjoyed it. I think about politics sometimes, but probably I will always try to stay linked to industry or academia, because I really, really just enjoy the environment so much. And I think I probably have a few minutes for questions from the audience. I hope I used about 15, I think.
Yeah, no, that was really well timed. I think, and a great talk, actually. You had so many twists and turns in your career. It's actually really interesting to see that. Yeah, I do sometimes myself put my blinkers on and I'm thinking, oh, where I'm going to be in BT in 10 years, and actually doesn't have to be that way. You can actually build over time and make decisions as they come. So very interesting. Thank you, Justin. If there's any questions that come up in the chat, Laura or Wendy, do you want to shout them out? But I'll just start with one quickly, because often in academia, we're encouraged to work with industry still, forming collaborations, etc., to kind of, create new research inspiration. But do you think your perspective of having worked in industry gives you a different perspective on those relationships for collaboration as an academic now?
Yeah, probably. I'm probably never going to go back for consulting or something like that. That doesn't seem super probable, but I am really interested in the problems, the data, of course, that's available in industry. But I know how difficult it is that if you're not making the right contacts in industry, right? You really need to find the folks that are in the business that were once academics themselves, are very sensitive to being academics. They have some appreciation for what it is that we do as academics, and we're not in the business of trying to sabotage the company by taking their data and publishing it in some paper or something like that. So I think this experience, I'm not just willing to go shake hands with the first guy who wants me a consulting job and think I'm going to get data out of it that I can write for a paper. It's not likely. I sort of need to find, at Intel, it was called an Intel Fellow. So these are sort of the level of folks that I need to interface with if I expect to utilize what's going on in the firm for academic purpose.
Okay, that's really interesting perspective, and I think actually that's something I've seen whilst at BT as well. So great. Okay, Laura or Wendy, was there any other questions that came up during the talk there?
I think there is one question maybe relevant to Justin. That is, what are the main difference between the US and Europe in terms of the comparison of academia and the industry?
Okay, so I will say industry-wise and probably academic-wise, although there's a huge variation in both in the US. The US is really ambitious, and ambition is cherished, and there's some sense in whether you're in top-tier academia or in top-tier industry, they want your soul for it, I think, which is a little different. It's one of the reasons I live in Europe, to be frank. It's a little easier. I think one thing that's interesting in academia, and why the UK was advantageous to me, because the labor laws are different. In the US, in academia, you often get your PhD at one rank, and at best, you will get an assistant professor job at the same rank, university. You probably won't get tenure, and then you'll fall down a rank, and you'll get placed eventually at wherever you sort of belong. The UK, at least, is where I've had my academic experience, because you almost automatically become permanent after 3 years. Like, this tenure idea is not so competitive. Getting in at the top is unlikely. Everybody sort of starts at the bottom, which was perfect for me because it was the only place I was ever going to start anyway. And then you can sort of filter your way up to the top as you're more successful as an academic. So that's one way to think about it. Like, I think in my case, if I tried to go to the US as an academic, it probably wouldn't have worked for me. I wouldn't have been able to enter at an R1 university. It just wouldn't be possible. But, now I can work my way up the ladder. And someday if I want to go back, I don't necessarily think that I want to for lifestyle reasons. My kids are Germans. That it could be possible, but the reverse might not have been.
Okay, that's great. Thank you very much. Okay, so we will move on to our fourth speaker and final speaker for today. So I think all of our speakers have been fantastic so far, but saving the best till last, maybe, Bahar. No pressure.
Oh,
No.
Peter, Jeremy, and Justin, I love the talk. And for a moment, I'm like just so comfortable, just like an audience. So it has been wonderful. So to listen to your stories. All right, I should just go ahead and share my screen. Share. And let me just first ask Lucy if you can view my screen. All
I
right.
can do, yeah, thank you very much. I'll let you take it away.
Oh, thank you. So I was just like thinking like where to start, and actually my daughter is a senior at high school, and these 2 weeks are the weeks of decision making. So when I was just like thinking of the talk, it kind of like started from the beginning, from my undergrad, because we are now spending a lot of time thinking those things for her. So I'm by training an industrial engineer. I started in Bilkent University, kind of the start of the academic life. This is in Ankara, Turkey. And after also getting my master's from there, I just was fortunate enough to end up at Northwestern University in Industrial Engineering and Management Sciences Department. And it was a very supportive, nurturing environment. And as we all think, my advisor, Bear Nelson, was also wonderful in guiding me through the path. And then my research there was mostly on multivariate time series input processes. So it was like falling under the umbrella of simulation methodology. After finishing the work, so I just worked on the theoretical side of things. As my first job, I ended up at Carnegie Mellon University. So I was in the industrial engineering or engineering school so far, and the business school environment was a little bit like different and a little challenging and uncomfortable for me, and which actually turned out to be a great thing, especially for where I am now. And I have been just like also trying to find pictures on the internet just to show how the schools looked at the time. So Carnegie Mellon Business School looks much nicer. So I was just looking at where I started first. So one thing that kind of like challenged me when I started at the Tepper school was that I had to do something about my research. So it had to be more business oriented. The work I was just doing was mostly technical. It was methodology driven. So I was just like fortunate enough just to have senior professors in the school and in our group that were mentors, and I just learned a lot from them. Through that, I was able to work on some industrial problems. So it just helped me a lot. And another thing that was challenging was teaching in the MBA program. So when I just first started, I was actually teaching simulation modeling, and the students in the MBA program of the Tepper at this time and are still were quite quantitative. So there was definitely some space, but then I was just showing proofs. It was just very hard for them, and then the feedback was quite eye-opening and tough to take at the time, but it kind of like pushed me how to communicate all that work I had been doing and how to actually create the story. So then everything just turned into more case driven, and again, it is how it should be, but it was just also a learning process for me at the time. So another thing about teaching in the MBA program was that, okay, like I had to change the teaching style. I had to learn how to communicate better. And then I also had great MBA students who would just like come and ask. And one of them, who turned out to be still one of my co-authors today, is like he just started to ask questions about real options, which I really didn't know much about at the time. So it's like finance, operations, interface. So it was a kind of like time where I had to learn, and then I had to go and teach in the classroom. So that teaching actually also pushed me a lot to learn and then also to bring to the research that I was just doing at the time. So in that academic environment, I just like owe a lot to kind of like what I am doing today. Let me see. All right. And then it was in 2014 when I left Carnegie Mellon and I started at General Electric's Global Research Center. So this was from 2014 to 2018, and today I'm at SAS Institute. It's just going to come very soon. I always, during the time that I was in Carnegie Mellon, I always commuted. So my kids and my spouse were in a different state, and I was in Pittsburgh. So just we kind of like managed it. And of course, he was working at General Motors at the time through the tough times. It just didn't also seem to be a bad idea to kind of be in different states, but we kind of got stuck in that. And it was around the time that our younger one, it was a little bit challenging. So I was getting a lot of help just to manage things on the home front, but I was still absent, and it just started to have a little bit like consequences. And then I just started to look for academic jobs in the upstate New York, but Muscatine area in Albany. And then I'm like, okay, so maybe I should just look into where my spouse is working, global research, which I really didn't want to. And then, of course, like I asked my husband, do you think I can do this? And he's originally from Germany, and he's very clear. Like he just says, like, Bahar, I don't know. I'm like, what? So anyway, I just started to work there. I just didn't think that I would have any difficulty in transition, but it was a different environment. And then there was a question like, how is academic experience viewed in industry? So I had already spent 12 years at Carnegie Mellon University, and I just like started at GRC, Global Research Center for short, and I was hired as a senior scientist. And we had also principals, and then we had chief scientists. So I was hired as a senior scientist, and we had leads and associates that are younger. Even though I was hired that way, objectively, like my experience, like was helping me with the transition, but objectively, it also didn't help much because I had never really worked with customers the way it was just being done at GE. And then it was just different while I was at the university and then working with some companies, but again, they were geared towards kind of like writing applied papers, if you will. So the customer experience was different. So, but then it was also a great place for me to start because the life in the businesses was much faster. So this pace was still slow at Global Research Center. And even for the research center, I was quite slow. So that was kind of like my first thing, like, okay, they asked me, hey, Bahar, this is the problem. How long it's going to take us and what's the budget? What should we put into the budget? And those questions would free me. I'm like, I just don't know. I just need to just write this down, do my literature survey first. And just there was no time. So again, with all the things like I have done, like there was always some feeling of being uncomfortable, but then I was also very lucky in terms of the people I was with. So you kind of like learn the process. And then another thing is that, which I actually had not thought about it when I was just starting there. General Electric was a hardware company. Now SAS is a software company. So these two are different too. So at GE, I had the opportunity of working in interdisciplinary research teams. And till that time, in the academic environment, I would work with some colleagues and students, but the definition of teamwork became something completely different when I just started at GE. I would just like work with chemists, physicists, engineers of different disciplines, software engineers, financial analysts. So we would all come together and work together. And then in the beginning, I also had a bit difficulty in understanding the language, the terminology that was being used. And it will just come a couple of slides later. And then I started to take these like GE Six Sigma trainings. So then you will also learn the lingo that is being just spoken. And another thing is that I was in the software sciences and analytics, and then I would work with colleagues in the hardware piece of things. So it was also very good just to communicate. So that was also a challenge, even just to speak the same language in the beginning. And then the design thinking. So you just like slowly develop like how do you actually design the project, how should the deliverables should be. And Peter talked about the minimum viable product piece. Just if you're going to fail, just fail early and just have all that experience and feedback in. So it was also good. And another thing was that when I just started at GE, I had this kind of tendency, okay, that's a problem you want to solve, then let me take it and I will just solve it and just bring it to you. So I would have the tendency of not including the customer, and that was just one of my major mistakes when I started, and I was almost failing in one of the projects. And one of our senior colleagues, he says, Bahar, you know, you just need to have the customer have their hands on the project. You just need to figure out how to work together. So that was actually a great lesson that I just like take it today in my projects today too. So you just need to, I think, have the customers put their hands into the project so that you are both accountable of what is going to be developed and what's going to be delivered. Communication, I just have benefited a lot from my time in Carnegie Mellon from those MBA teachings. So you learn how to tell the story, you just learn how to explain things, hard theoretical concepts in a very simple manner. So because you are working with researchers, and then you are working with the managers, and then you eventually presented at the executive level. So that level of communication, you just need to be able to adjust depending on the room that you are speaking to. So that was very useful. And again, working in a interdisciplinary research setting like that, we had different groups at Carnegie Mellon. So Tepper schools. So you kind of like work people with different backgrounds. So that was also quite helpful as a starting point. And then you just build onto it. And another thing about working here is that I think I was very lucky. We would work with internal customers. So I would work with GE Aviation. I would just work with colleagues from GE Power, but it was all one company. So therefore, the customers were internal, and it was also somewhat a good beginning and comfortable beginning for me. So this also made me a little bit shut down when I just started GRC, because I like, oh, the network. The more important thing is that I built the network inside the company, because you need to build your relationships, and then when there's something work to be done, they call you. So it was a period where I kind of disappeared. So it just took me several years to go back to the conferences. Instead, I was just working on creating reports, talking to people, reaching out to people within the company, which is completely different now, but it was kind of how it worked out at the time. And again, it's like I learned about the aviation, manufacturing, energy, and utilities projects. At some point, I was working on renewable energy projects. So it was like how to operate those wind turbines. I was working with controls, engineers. I had to learn with wind fields. I had to go back to some physics books. So, and I'm like, oh, okay, so it's all about learning. So it was also a kind of mindset shift. I started with simulation theory. I had to go towards like supply chain management at Carnegie Mellon. And it kind of like gives you, yes, it's about growing, it's about learning and just making links between the things. So it was quite nice. And manufacturing, I also spent quite some time on learning about additive manufacturing. And of course, like there's the learning piece, which is also very much encouraged by these corporate learning programs, but you also need to focus. So all of a sudden there are these software vendors coming. It's like, yes, you can learn something all the time, but it can also be kind of like difficult to focus for some of us. So you still need to sit down, do your project and deliver, and then apply for the patent if there's an opportunity to do that. Produce papers, white papers to share. So you need to be aware that like, what is the KPI, key performance indicators for your performance, and are you delivering it? So how are you managing your time? So it's great to be able to work in these learning programs, but you still need to produce. So I think that was also something I kind of like struggled in the beginning. There was the analytics engineering program at GE. It was a one-year program where you could just like take different courses, but then you also kind of like had to work on kind of couple of month project. You had to find it from the businesses. So this is where I'm like, okay, the data science, deep learning concepts, I could just like bring it to the projects. So that was some program which was very helpful. It was almost like a one-year master's program, which I really enjoyed. Six Sigma quality, green, black, and master belt trainings. I just didn't have the time to do master belt, but I had great time and learned a lot on green and black belt things, and everything was of course geared towards like measuring hardware. So how do you adjust your equipment? So sometimes it was difficult to take those things to bring it to the software. And another training I really enjoyed, probabilistic methods, Bayesian hybrid modeling, kind of like takes you Bayesian optimization topics. It was just great just to see how that is being done in the company and what type of problems. So I really benefited from these learning programs a lot. When I first started at the research center, I was like, had this mindset. I would just tell my students, like, I'm not teaching anymore. Like, what is my calling? Like, right, we would do research, and I would still teach. So you just benefit the students. So all of a sudden, teaching disappeared, and of course, like, you just work with different colleagues, you teach each other, but it was not the same. So I think that teaching disappeared, just was a little bit like hole in my life for a while. And another thing is that I'm like, I just need to continue to write papers. And during the week, I really don't have much time. So I would just like actually spend my weekends just to work on some other side projects. And then it just became very difficult because the week was starting. I was very tired. And I'm like, okay, I just need to be more balanced. I need to take the weekends off. And I just need to start fresh, because when you are working with customers or when you are in brainstorming sessions. You see, I'm not paying too much attention to the time because I don't have my clock.
Just a couple of minutes, if that's okay.
Okay, of course. And now I'm in the SAS Institute in Analytics Center of Excellence. I started here actually February 2018. I recently had my 4th year anniversary. We are a kind of like 16-person group. We are staffed with consultants and developers, and we provide expertise in OR and AI. Actually, so we are located in R&D. I spent 50% of my time. Of course, as a guideline, you kind of see what the customer, where the customers are, what they may need. But then we work directly with the customers. It was also a switch from internal customers at GE to the external customers. So then you have, of course, a different kind of accountability. And it was okay, maybe you would be off with your time and estimations, but with the external customer, you had better be accurate. So there's a contract in place. So it was a little bit of a pressure in the beginning. We work on, again, like work with projects from various verticals. So consumer products, healthcare, and life sciences also became the verticals I started to work on and learn about them. I just had a point there on the previous slide. I'm just trying to remember that. Yes, actually what our group does 50% of the time, okay, we work on direct billable customer projects, and 50% of the time it should be on research. But again, like the research is now different, right? You can now do research in vacuum anymore. So for example, one thing when I sometimes think about, like, would I go back to academia? I'm like, oh, I know that I'm kind of losing my in-depth research skills, because the industrial research and academic research may be different things slightly. So I don't spend too much time to do proofs anymore. Sometimes we do, but again, it's just driven by the customer projects. But then we just look at how we can just produce patents, and then like writing the papers, and writing a paper for SAS Global Forum, which directly targets the customers. So the second one is now more important. So I just adjust my priorities. So that's another reason, like I sometimes feel like I'm slowly losing my in-depth research skills. In terms of work-life balance, once I kind of like figured out how to do the balance myself when I started the G, and even at SAS more, it has been also a blessing. And I was, especially at SAS, we have a life and science center, and they just give you guidance, and the kids were just growing at the time. So I would even just get suggestions about their high school selections. And one of the person who would just advise us was a high school counselor, and they just give kids the ACT exam, SAT exams, and they help you with your journey of college applications. And I was like, oh, this is wonderful. And just, they help you so much. So again, depending on where you are. So I have always been quite surprised about how much support you get about your work-life balance. But again, it's all up to you just to keep that balance in place. And I think I can just stop here.
Oh, thank you so much, Bahar. That was really interesting. I actually didn't know that you'd moved to SAS after GE, so that was cool, because I think we met maybe 2018 when I started going to winter sim style conferences. But yeah, so if anyone's got any questions for Bahar specifically, do put them in the chat. But I did have a quick one, and maybe this is because I know a bit more about your background. But so you've got lots of links in academia, and do you find that useful for, I don't know, on the research front, if you're looking into a new area, you might already know people working in that you can contact from your previous academic life? Is that advantageous, or do you find that you like to dive in there yourself?
Oh, I just do contact the colleagues. So I think like it was also a kind of switch in behavior of mine. I think back in the days, I would just try to figure it out myself. And once I started in the industry, you also don't have much time, and then it's okay to ask. So I would sometimes be a little bit embarrassed to ask questions that kind of disappeared. So ask questions. And it's also great just to get the viewpoint of the academicians who just write these papers, and sometimes it helps you a lot just to make connections. I worked with actually Barry, and we have also been trying to figure out to start on a new project. Well, it says, but it was just also difficult in the beginning just to work with a colleague from academia, because you need consistency, right? Like in the work you do. And I just cannot be consistent in terms of the time I allocate. So I start, but then I had to stop. Oh God, what was I doing? I go back to my notes, and again, you lose that steady, focused attention. So this is why I just contact, and I ask a lot of questions, and whatever I do in my communication or just trying to work with colleagues from academia, it needs to be viewed into my daily projects. It might not be necessarily into a customer project. Maybe it's another type of project, because another thing we do, we work with the customers. Sometimes the products cannot deliver because the customer's problem is too complex. Then we go to the developers and they put their hands into the products. We solve the problem, and the way we solve it is incorporated into the next release of the product. So.
Okay, that sounds sensible, trying to link everything that you do together. So, Laura, is there a question in the chat I can see?
Yes, so the question, which is, what is the difference about networking or connections with others in academia versus industry? So it's kind of linked to the previous question, but a little bit different.
Of course, like when you just like talk to the colleagues from industry, it's very much like the business problem oriented, and the way you solve the problem may not be very transparent. And of course, like you kind of like then follow what is going on through the patents that are being published. With the colleagues in academia, of course, like I have business problems, customer problems, ones either I'm working or I worked in the past, but it was difficult. So I kind of like try to direct my questions and networking to what I don't know, what it would be great to know. And another thing is that initially when I started at GRC, I was like, am I not gonna do research anymore? How is this gonna work? So it was just not clear to me. And then slowly, it's like there's a question about the theory, a new method, and then like, hey Bahar, what is going on in this area? Oh, do you know this paper? And I'm like, oh my God, like I just need to keep on top of everything. So of course, like where I originated in terms of research, like I just track what colleagues are doing, and I just try to take it into different areas as well. But I just like my networking with academia is very highly motivated by that as well. And then again, it's all about learning. It's just wonderful to talk to people, learn from each other, and just still bring it. We are in a very exciting and fast-moving profession. And we are lucky enough just to be able to bring the systems thinking, system design into the difficult problems we are looking at. So
that's a great answer. I think if there's one thing I've noticed about the 4 speakers that we've had today, it's that you all seem to be quite motivated by new challenges and learning, which is great, because I think you wouldn't be in academia, would you, if you weren't interested in continually learning. So Okay, I think we just got a couple of minutes. If there were any questions, Laura or Wendy, to send out to the wider panel. If not, then maybe we can.
I forgot a question about a lot of the speakers have sort of moved between many different companies, and I just wanted to ask a question. I'm not sure who wants to answer it, but you know how difficult it is to sort of adapt to a new company, and are there lots of new like techniques that you have to use that are different from your original research background, and how you find that?
Well, that's go on, Justin, because you just put his hand up.
No, I was just going to say it's a two-edged sword, of course. Adapting is always complicated, but there's so much energy that you get from making the switch. There's so much excitement. You're in it. You're motivated, and that's like being early on the learning curve is just hugely valuable for you, as we've talked about the learning. So, you know, you do some adapting, but that's the fun part.
Do you want to add, Jeremy?
Yeah, absolutely. To Justin's point, I think there's the dual opportunity. There's the opportunity you have to sort of reinvent yourself almost when you move to a new place, and there's obviously the opportunity for the company to sort of slightly, depending on the size of the company, to reconfigure itself around the new people it hires and the new talent it takes on board. So I think I was able to sort of grow and develop every time I moved, which was really, really nice, and I think hopefully sort of helped the company then sort of realize new opportunities and new things. It takes about 6 months, I find, to really settle and to really find your confidence in a new organization, and that was true whether it was an academic institution or a new company. So yeah, it is a bit, but I use that sort of rough rule of thumb for anyone that I hire as well now, because I'm looking to help them develop through that 6 months and really find the best, sort of get the best out of them for that period. Yeah.
Great question, thanks, Laura. I don't know if anyone else wants to actually add to that as well.
I will not say anything different, but like when I just went from General Electric to SAS, and I'm like, oh, I work in industry, I just started, I spent 4 years, it's just going to be, so I was of course naive on that. It just takes time because you just don't know the setting, and then the group or the company you go into, they have their own dynamics and they are working together and you're from outside, and then they often assume, because again, I just joined as a senior, they may assume that you know a lot. And again, just ask questions. You actually don't know much. So, and it's a painful process and it's an uncomfortable process, but then there's so much energy too. So just push forward, enjoy the thrill of it, and eventually in 6 to a year, everything works nicely and it feels like you have been there for a longer amount of time.
I'm just coming up to just over 6 months at BT, and I found that, until you're 6 months in, you don't have anything to moan about. So you only find out the weird things and the niggles about a business around this time, and it's like, oh yeah, I can live with this, but but you don't really know it until then. So it's quite interesting. Cool. Right. Oh, we've got another question just come in. Okay, so I'll just read this out and then people can take it. So, are there things that industry and academia should learn / take from each other in our OR field? And which of those is more likely to do so? So, Peter, do you want to take that one?
Yeah, sure. I'd be happy to. The thing that an understanding of what problems are important, I think that that's a thing that people in academia could take from industry. Definitely when I was working at Uber in 2016, 2017, there were lots of papers about ride sharing coming out, and the assumptions that would be made in the paper, not that assumptions are necessarily bad, but the assumptions that they were making were focusing on things that were not really part of the real problem. Gradually over time, it's gotten better, and I think kind of the academic understanding of what aspects of ride-sharing problems are important has improved. But yeah, I think that's probably true more broadly.
Cool. Yeah, I think that was.
I don't know what other panelists think.
Yeah. Anyone want to add to that?
I think I found there is a general blind spots that people that people, not people particularly, but just industries have around particular areas of scientific sort of development, and I'd say one of them, we sort of talked about this previously, Lucy, is simulation. I would say another is formal methods in software development and formal proof around software. I'd say a third is concurrency modeling in processes. Most of the things that we put in place run concurrently with lots of other processes, and the theoretical understanding of that is pretty woeful. So there's tons. There really is. I mean, that's just three, right? And I think so there's a lot of companies that are targeting particular areas and are getting much more not just up to speed, but they're actually contributing. They're actually doing some really exciting things. And I think Peter sort of told us about some of those amazing experiences there. But I think there's certainly some blind spots where we could take from not just OR but from CS, from maths as well. But then there's some giving back as well, not least some of the discussions I had with Christine about looking after people.
I guess without the flexibility of careers, though, that you guys have actually had, people wouldn't find out about these types of things. So yeah, hopefully in future, that's what I think the way forward. That's what I want to do with my career, like try lots of different things. So yeah, okay, great. So I think
just one other thought is that I wish that there was an easier way for folks in industry to find out about the new methods that are developed in academia that are good and useful and that they should try. It's so hard. Like there's all kinds of barriers. One is paywalls for papers. I'll suggest a method to somebody at Uber and then they can't get the paper. Another one is the incentives. Like when I write a paper academically, my incentive is to make it seem all fancy and it's the most amazing method in the world, whether it is or not. And then that makes it that's good for me as like the individual researcher, but it's bad for my area because then a person in industry can't figure out like the simple thing that they should be using that's really going to move the business forward. It'd be nice to have some kind of a summary, a quarterly summary or a yearly summary or something of like, hey, you should try these 4 methods. They're really great. They're going to work for you.
Someone needs to set that up.
When I read the papers, I try to create a flow chart for myself, right? Like there needs to be a framework. So I just like, first don't go into the details, but like what are the assumptions, what is the offline learning, online learning pieces, prediction of them. So like even like at the moment I'm working on just creating a digital twin framework. So there's so much out there. So then from there you take it into composable elements, and then you can really go specific methods. So yeah, I mean, the framework and then the composable elements, and then you can start maybe matching the methods at that lower level. So, and then it just brings you some modularity in terms of the work, and then it also allows you faster, and then you create more time to connect to the academic work. So the way I just read and try to track the work has changed a little bit, and I definitely miss the times that I could sit down, take my notes, try to understand the prose, but I just don't have the time. So in a way, I am looking at all that hard work that was put in, years of work, but then I just only have time to look at it at a superficial level in some ways. So it's like coming to what Peter says, if it would be a summary, and it would, that summary, not only in words, I wish it would be kind of more illustrative manner as well. So I would just find it so useful.
No, I like that idea. That seems like really sensible. So I suppose conferences are a way of doing that, and you just got to hope that the company you're with are happy to, although I found some conference sessions inaccessible myself. But yeah, okay, great. Well, I think we'll just have, maybe because we're coming up towards the time, I want to do one last shout out, and then we'll do 5 minutes of breaking out into rooms. But thank you to all of our speakers again. I've really enjoyed today. I've really enjoyed looking at hearing about all your careers, and the comments that are coming in the chat are saying the same things. So yeah, it's been really lovely and rewarding. The last thing I wanted to just shout out is a few of you here might not have heard about the researcher database. So if you're an ECR and you haven't heard of that, on the OR Society website, you can just, if you go on, you can apply to be on it, and it's just a database of researchers in the UK where you can put down the discipline you work in, and the position you're at the moment, and which university, etc. And then people can find you, if they're looking for somebody to collaborate with in simulation, which is my area, or optimization, they can find you a little bit more easily. So we're hoping to spread that out a little bit by getting more ECRs on there as well, and more people collaborating with ECRs, which is only ever a good thing. So yeah, Carol's just put a link in the chat if anyone's interested in joining that. And our speakers are welcome to join as well. It's open to everybody. Okay, great. So Carol, are you there?
I am, yes. Now I can set up 3 or 4 rooms. Which would you like?
Just 3, that's fine. Yeah, so you don't have to stay for this. If you want to join us and have a little quick chat, we'll just do it for maybe a couple of minutes. Thanks, Carol.